Okay, here I've drawn a scenario on the board. I've used the beauty salon as an example. We just finished the beauty salon for project one. I've shown the splitter and the disconnect on the left side there. Obviously, there'd be more disconnects involved with that splitter and a main disconnect. But let's just focus on the beauty salon, the load side of that disconnect. So it's in blue. I've labeled it feeder, and that's the primary side of the transformer, or we could say the high voltage side of the transformer. You can see my transformer, it's XFMR. That's just a shorter way of writing down the word transformer. It's hung by the ceiling above the panel in the beauty salon. Below the transformer there, that black line, that's just the T-bar, so I would remove the tiles and there would be my transformer above the ceiling. So it's a ceiling hung transformer. I have a primary feeder, conduit, raceway, what have you, going into the primary side of the transformer. On the other side of the transformer, I have a larger blue raceway labeled secondary, going down and feeding the secondary disconnect of my beauty salon. I got labeled 80 amp fuse, and then that disconnect then feeds into my panel for the beauty salon. So the 100 amp disconnect, those 80 amp fuses on the secondary side of that transformer, that's from your print. All the disconnects you have on, I believe it's drawing E5, those will remain the same for the secondary side of your transformer. We're not changing what these units are getting fed with as far as current is concerned. We're not changing the panels or the disconnects that feed the panels. What we want to calculate now is that feeder. So what we have to do is we have to calculate the size of the transformer so we know what size the feeder, raceway, and conductors are going to be feeding the transformer. So to calculate the transformer for each unit, I want you to look at the size of the disconnect. So for the beauty salon, it was a 100 amp disconnect. What can I load that disconnect up to? I can load it up to a maximum of 80% of 100. So I can put 80 amps on that disconnect 100% of the time. Now, I know the beauty salon has 80 amp fuses, so we'd be 80% of 80 amp fuses, but we could, increase capacity with the beauty salon. Perhaps they get busier, they add more chairs, they add more personnel working in there. They pull out those 80 amp fuses, they put in 100 amp fuses, and that transformer will be able to supply the ampacity that unit requires. So look at the disconnect feeding the units from your prints, and then do 80% of the ampacity of the disconnect. So in this case, it's 80% of 100, so 80. So your kVA is going to equal your current, the current ampacity, or the possible ampacity we could supply. The current times the line voltage, which is 208 because it's the secondary of the transformer, times square root 3. So I took the 80, which is 80% of 100. So 80 times our line voltage on the secondary, which is 208 volts, which hasn't changed from our original prints, times the square root of 3 because it's three-phase. I get a kVA equals 28.8. There is not a 28.8 kVA transformer. That's not a standard size. The next standard size is 30 kVA. So I would install 30 kVA above the ceiling space in my beauty salon. And now the next thing we'll look at is, how do I size my primary conductors and my feeder for the primary of the beauty salon? And the beauty salon is our example. Now the secondary raceway and the secondary conductors, that will be what the print has currently listed.